Hello there. So let's analyze this circuit. So what we see here, we have this equivalent model or equivalent circuit for a BJT. And we see there are three pins: collector, emitter, and the base pin. Obviously, the voltage drop between the base and the emitter is called as VBE, that is base emitter voltage, with base positive and the emitter is at negative, where the voltage drop across the collector and the emitter is called as VCE, with collector at the positive potential and the emitter at the negative. Obviously, there is a third drop which is between the base and the collector, which is called as VBC. Let me draw it with the small letter, actually, because we are using the small letters for other voltage drops. So this will be VBC. Now, there are three currents. So base current, emitter current, and the collector current. So IB, IC, and IE. So obviously your emitter current, if you apply the KCL at this node, so your emitter current IE is the sum of two current IB plus IC, and the IC is modeled as GM times VBE, where GM is the transconductance of the amplifier, which is calculated by the ratio of the DC collector current divided by VT. VT is your thermal voltage. Okay, and thermal voltage, its value is about 25 millivolt at room temperature. Okay, so that is how you have this dependent current source. It means the current IC is dependent on the input voltage VBE, that is this voltage drop. So that's how you model. So it is basically a voltage controlled current source. So BJT can be modeled as voltage controlled current source, where the input voltage across the base emitter junction controls the collector current. And obviously IC is also beta times IB, where beta is called as DC current gain. DC current gain. Now finally, you have a current which is flowing from collector to emitter, and the modulation of that current is denoted by the reciprocal of this resistance, which is called as conductance. So it can be modeled by connecting the collector across the collector and the emitter pin. You model this effect by RO, which is called as an output resistance of the BJT, resistance of BJT, and RO is V divided by I. And what is that? So it will be VCE, that is this voltage, divided by the current, that is IC. Okay, so delta RO would be delta VCE divided by delta IC. So that's how you can actually understand the small signal model or small signal behavior of the BJT by drawing a small signal equivalent circuit and identifying the direction of currents and the voltages and modeling the effect of finite output resistance.